day everyone, and welcome to our next lesson, which is special products. Our most essential learning competencies are: the learner uses models and algebraic methods to find the product of two binomials, product of the sum and difference of two terms, square of a binomial, cube of a binomial, product of a binomial, and a trinomial. Let's begin our discussion on special products. There are binomials or trinomials that when you multiply the products form a pattern. Such are called special products. Using the laws of exponents, you will be able to find the product of a square of a binomial, sum and difference of binomials, cube of a binomial, and square of a trinomial. Let's begin our discussion by answering learning test number 1. All you have to do is to find the products of the following. Let's start with number 1. A plus b squared is equal to a plus b times a plus b, which is equal to a squared plus 2ab plus b squared. Next, number 2. A minus b squared is equal to a minus b times a minus b, which is equal to a squared minus 2ab plus b squared. Next, let's have number 3. A plus b times a minus b is equal to a squared minus b squared. Next, number 4. A plus b cubed is equal to a plus b times a plus b times a plus b. A plus b times a plus b is equal to a squared plus 2ab plus b squared times a plus b. Then a squared times a is equal to a cubed. Positive 2ab times a is equal to positive 2a squared b. Positive b squared times a is equal to ab squared. Then a squared times b is equal to a squared b. Then positive 2ab times b is equal to positive 2ab squared. Then b squared times b is equal to b cubed. Then combining like terms, we have a cubed plus 2a squared b plus a squared b is equal to positive 3a squared b. Then plus ab squared plus 2ab squared is equal to positive 3ab squared. Then plus b cubed. Therefore, we have a cubed plus 3a squared b plus 3ab squared plus b cubed. Next, number 5. A minus b cubed is equal to a minus b times a minus b times a minus b. A minus b times a minus b is equal to a squared minus 2ab plus b squared times a minus b. So we have a squared times a is equal to a cubed. Negative 2ab times a is equal to negative 2a squared b. Positive b squared times a is equal to positive ab squared. Then we have a squared times negative b is equal to negative a squared b. Negative 2ab times negative b is equal to positive 2ab squared. Positive b squared times negative b is equal to negative b cubed. Combining like terms, we have a cubed minus 2a squared b plus negative a squared b is equal to negative 3a squared b. Positive ab squared plus 2ab squared is equal to positive 3ab squared. Then minus b cubed. Therefore, we have a cubed minus 3a squared b plus 3ab squared minus b cubed. Next, number 6, we have a plus b plus c squared is equal to a plus b plus c times a plus b plus c. So we have a times a is equal to a squared. A times b is equal to positive ab. A times c is equal to positive ac. Then b times a is equal to positive ab. B times b is equal to b squared. B times c is equal to bc. C times A is equal to positive AC. Then C times B is equal to positive BC. Then C times C is equal to positive C squared. Combining similar terms, we have A squared plus 2AB plus 2AC plus B squared plus 2BC plus C squared. Did you find a pattern in the products when you multiply the binomials or trinomials in the learning task number 1? These are special types of polynomials. The first one is square of a binomial. So we have a plus b squared. So our first term is a and our second term is b. So first we're going to square the first term, then twice the product of the first and the second. Then we have square of the second term. So using the pattern above for a minus b squared, so we have a minus b squared is equal to a squared, which is the square of the first term. Then we have the twice of the product of the first and the second. Our first term is a and our second term is negative b. Therefore, we have positive 2 times a times negative b. Then we have the square of the second term, which is negative b squared. Therefore, we have a squared is equal to a squared. Then positive 2 times a times negative b is equal to negative 2ab. Then negative b squared is equal to positive b squared. Therefore, the answer is a squared minus 2ab plus b squared. Squaring of binomials, so we have a plus b squared is equal to a squared plus 2ab plus b squared. And a minus b squared is equal to a squared minus 2ab plus b squared. For example, we have 2x plus 3 squared. So first, we're going to get the square of the first term, which is 2x squared plus twice the product of the first and the second term. So we have 2 times 2x plus times 3 plus squared of the second term. So we have 3 squared is equal to 2x squared is equal to 2x times 2x is equal to 4x squared plus 2 times 2x times 3 is equal to positive 12x. Then 3 times 3 or 3 squared is equal to positive 9. Therefore, we have 4x squared plus 12x plus 9. Next, number 2. X minus 2y squared is equal to, so we're going to square the first term, which is x squared, plus twice the product of the first and the second term. We have 2 times x times negative 2y plus the squared of the second term is negative 2y squared. Therefore, we have x squared is equal to x squared. Then we have positive 2 times x times negative 2y is equal to negative 4xy. Then negative 2y squared is equal to positive 4y squared. Therefore, x minus 2y squared is equal to x squared minus 4xy plus 4y squared. Next, we have the square of a trinomial. So we have the first term, the second term, and the third term. So first, we're going to square the first term, square the second term, then square the third term. Then we have twice the first and second term, then twice the first and third term, and twice the second and third term. For example, square root of trinomial, we have a plus b plus c squared is equal to a squared, the square of the first term, plus b squared, which is the square of the second term, plus c squared, which is the square of the third term, then twice of the first and second term. So we have 2 times a times b, plus twice the first and third term. So we have 2 times a times c, plus twice of the second and third term. So we have 2 times b times c. Therefore, a plus b plus c squared is equal to a squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc. For example, 2x plus y minus 3z squared is equal to, so we have the square of the first term, 2x squared, square of the second term, which is y squared, plus square of the third term is negative 3z squared, plus twice of the first and the second term, we have 2 times 2x times y, plus twice of the first and the third term, we have 2 times 2x times negative 3z, plus twice of the second and the third term, we have 2 times y times negative 3z. So, we're going to have 2x squared is equal to 2x times 2x is equal to 4x squared plus y squared plus negative 3z squared is positive 9z squared. Then we have 2 times 2x times y is equal to 4xy plus 2 times 2x times negative 3z is equal to negative 12xz times plus 2 times y times negative 3z is equal to negative 6yz. Therefore, we have positive 2x plus y minus 3z squared is equal to 4x squared plus y squared plus 9z squared plus 4xy minus 12xz minus 6yz. Next is sum and difference of two binomials. So we have a plus b times a minus b is equal to a times a, which is the product of the first term, then plus product of outer terms, which is a times negative b, plus the product of the inner terms, which is a times b, plus the product of the second terms, which is b times negative b. So, sum and difference of two binomials, we have a plus b times a minus b is equal to a squared minus b squared. For example, x plus 2y times x minus 2y is equal to x squared minus 2y squared is equal to x squared is equal to x squared minus 2y squared is equal to positive 4y squared times negative is equal to negative 4y squared. Therefore, x plus 2y times x minus 2y is equal to x squared minus 4y squared. Another example, we have 2a squared minus 3b times 2a squared plus 3b, which is equal to 2a squared squared minus 3b squared. So 2a squared squared is equal to 4a raised to 4 minus 3b squared is equal to positive 9b squared times negative is equal to negative 9b squared. Therefore, 2a squared minus 3b times 2a squared plus 3b is equal to 4a raised to 4 minus 9b squared. Another one is x plus 3a minus 2 times x minus 3a minus 2 is equal to, so we have x squared minus 3a minus 2 squared. So we have x squared is equal to x squared minus 3a squared minus 2 times 3a minus times 2 plus 2 squared is equal to x squared minus 3a squared is equal to positive 9a squared. Then negative 2 times 3a times 2 is equal to negative 12a plus 2 squared is equal to positive 4. Therefore, we have x squared minus 9a squared minus 12a plus 4 is equal to x squared negative times 9a squared is equal to negative 9a squared. Negative times negative 12a is equal to positive 12a. Negative times positive 4 is equal to negative 4. Therefore, we have x squared minus 9a squared plus 12a minus 4. Next is the cube of a binomial. So, cube of a binomial, we have a plus b cube is equal to a cube is the cube of the first term plus 3a squared b is the thrice the product of the square of the first term and the second term. Then plus 3ab squared is the thrice the product of the square of the first term and square of the second term. Plus b cube is the cube of the second term. So we have cube of binomial, we have a plus b cube is equal to a cube plus 3a squared b plus 3ab squared plus b cube. Or a minus b cube is equal to a cube minus 3a squared b plus 3ab squared minus b cube. For example, a minus b cube is equal to, we have the cube of the first term, we have a cube plus the rise of the product of the square of the first term and the second term, which is 3 times a squared times negative b, plus the rise of the product of the first term and the square of the second term, which is positive 3 times a times negative b squared, plus the cube of the second term, which is negative b cube. So we have a cube is equal to a cube, then positive 3 times a squared times negative b is equal to negative 3a squared b. Then we have 3 times a times negative b squared is equal to positive 3ab squared. Plus negative b cube is equal to negative b cube. Therefore, a minus b cube is equal to a cube minus 3a squared b plus 3ab squared minus b cube. Another one is 2x plus 3y cube is equal to, we have the cube of the first term, which is 2x cube, plus the rise of the product of the square of the first term and the second term. So we have 3 times 2x squared times 3y plus thrice of the product of the first term and the square of the second term. So we have 3 times 2x plus 3y squared plus the cube of the second term, which is positive 3y cube, is equal to 2x cube is equal to positive 8x cube. Then we have 3 times 2x squared times 3y is equal to positive 36x squared y plus 3 times 2x times 3y squared is equal to positive 54xy squared plus 3y cube is equal to positive 27y cube. Therefore, 2x plus 3y cube is equal to 8x cube plus 36x squared y plus 54xy squared plus 27y cube. Another one is 3a minus 2 cube is equal to, so we have the cube of the first term, which is 3a cube, plus thrice of the product of the first term and the second term, which is 3 times 3a squared times negative 2, plus thrice of the product of the first term and the square of the second term, which is 3 times 3a times negative 2 squared, plus cube of the second term, which is negative 2 cube, which is equal to 3a cube is equal to positive 27a cube. Then we have 3 times 3a squared times negative 2 is equal to negative 54a squared Then we have 3 times 3a times negative 2 squared is equal to positive 36a plus negative 2 cubed is equal to negative a. Therefore, 3a minus 2 cubed is equal to 27a cubed minus 54a squared plus 36a minus 8.